cycle, like a software development life cycle. Why software development? Like even in the case of human life cycle, you know, the kids born, right? So we take birth and then we become adult, we go to job, and after a while, after some years, we get retired. Like how a human, each human have a life cycle. Even in the case of machine learning model, or you take any application development, it has a life cycle. So as part of the first part of your life cycle is your first stage of your life cycle is problem definition. As part of problem definition, we define what problem that we are going to solve. Like as a human, right? So for what purpose? What is our future goal, right? So you want to be a doctor or engineer or actor, right? So that is what we decide about our future, right? So what purpose we want? What is the purpose of our life, right? So you decide. So I wanted to be something like this. Before you start building a model, you need to have a solid problem. You need to define the problem definition well ahead. Okay, so what problem you are going to solve? Okay, and next step is we are all set to you need to collect the data. You need to do the data collection. Once you collect the data, you need to perform the exploratory data analysis. By exploring the data, you will be getting insights. You might be getting the business, sorry, you will be getting business insights, and you will get some insights about the quality of the data also. In case that data quality is not good, you need to pre-process the data. Okay, you need to pre-process the data or prepare your data. Okay, and then if required, you need to do the feature engineering. So what is the difference between these two guys? Machine learning people can tell this one, machine learning or data scientist. What is the difference between pre-processing and feature engineering? I think already I discussed about this. What is the difference between these two, pre-processing and feature engineering? Pre-processing is something like data cleaning. If you have any data related issues, for example, you have redundant data is there, duplicate records are there, or in case of any missing values, any anomalies, outliers are there in your data set. So in that kind of situation, you need to first address those issues. It's something like garbage in, garbage out. If you give the garbage to the system will give you back the garbage. Similarly, when it comes to any analytics project, whether it is a machine learning model or deep learning, or whether it is if you are going to create a report in Tableau or Power BI, you need to make sure that the given data is clean. Okay. Otherwise, you need to do the data cleaning. Okay, that is what we do it here as part of data pre-processing. Okay, good answer here. Future engineering is more about taking or making valid features that boost. Okay, what do you mean by valid features or taking features? Someone answered, very good. So good answer. Pre-process more of data cleaning. Okay, feature engineering is more about taking or making valid features that boost model. Based on the existing feature, you are going to create some new feature, right? Sometimes, right? You may require to create some new feature. For example, you have an age column, and the age you have numeric values, and you want to create another column, another feature. See, here in the case of machine learning or in the case of AI, right? If I say a feature, that means columns. In the table, we have columns, right? Instead of saying columns, we call it as a features, okay? So what we do is, right, we take the existing feature, we'll try to create a new feature. For example, age is a feature, right? In that age feature, we have the numeric values are there, 25, 16, 18, 20, 35, something like that, okay? And you want to create another column by the name of age group. So wherein you want to uh, you want to classify which customers are falling in which age group in terms of text. For example, teenagers, the customers, age between 13 to 19, those customers falling in that range, in that age group column, you flag them as teenagers. And people about 20 and 25, you mention, you flag those customers as young age group. Why you need to create age group column? Because you want to do some kind of analysis based on that. So which age group of people, spend, you want to understand their purchase patterns, purchase behavior, and how much they spend. You want to understand, you want to do some kind of analysis. So in that kind of situation, that is really helpful if you have that one. Again, you can make a, you can do, you can make a tailor making offers, tailor-made offers to those customers, targeted customers. Okay. So for that purpose, you may have to add additional columns. For example, you have housing data set. So in the housing data set, you have features are there, something like square feet and bedroom, number of bedrooms. These are the columns are there currently. And you want to add some additional column, price per square feet, right? So, so maybe right by adding additional column, it may boost your model performance, right? So in that kind of situation, you will do feature that is called feature engineering. The next one is feature selection. Okay, I have in my given data set, I have hundreds of columns are there. So which features are really helpful in terms of predicting my outcome variable? Okay, so you need to do feature selection. Various tools and techniques are there. So you can do feature selection, right? Using those techniques. What are the, how do you do the feature selection? Anybody has any idea? So what are the tools are available? What are the tools and sorry, what are the techniques that I can use it to do the feature selection? Yes. Apart from that, hmm. Anybody else? Okay, I could see some good answers here. Okay, very good. Yeah, hyperparameter tuning is that we do it later. Okay, so before that, you do some feature selection here. So in you have something called SageMaker. You have something called autopilot, right? You can use autopilot in SageMaker to automate your feature selection. And then manual selection also you can do it. The SageMaker notebooks. You using the notebooks also you can do that. And the other way is right. There are different techniques like SHAP, and Lasso, and Boruta, right? So, and mutual information. How many have heard about mutual information, using which we can do the feature selection? Anyhow, we will be discussing it later point in time in the upcoming sessions. And then the next step is the model selection, model training, and parameter tuning. So, what do you mean by model selection? After you choose the specific set of features that will help you to improve your model accuracy, what you do, right? Or the features that are important for your model to boost the performance. The next step is what you do is you select the model, you do the model selection. So which model can I use it? You start with some model and you baseline it, right? And then you train that model. For example, for the sake of example, you start with a simple linear regression algorithm, and then you train that linear regression model with the historical data, and then you do some kind of tuning, and then you evaluate the model performance. With the model performance up to the mark, then you good to go with deploying the model. That's how you proceed further. If the model performance is not good, so what you do is you choose some other model. You take XGBoost or random forest and retrain the model, and then do the hyperparameter tuning. And then what you do is you evaluate that specific models. And if that model, whichever algorithm that improves your model performance, right? What you do is you proceed with deploying those models. Before that, what you do is you build the UI and all user interface, so that the end users can key in their data to, to make a prediction, right? So in their user interface, okay, something like Streamlit, you built a simple one is the Streamlit as a user interface, wherein the users enter the number of bedrooms and square feet of the house and the area, and then when they hit the predict button, your algorithm will get triggered and it will give you the predicted value in that thing, right? So so you build that thing and then you deploy the model, and then once you deploy the model, you enable the monitoring. This is very important. It's not like deploying the machine learning model on your production system is one-off task. It's not a one-off task. you need to monitor the model continuously. In case the model performance is not up to the mark, you need to, yeah, PCA is also one of the techniques we use it, right? Yeah. So you need to keep monitor your, model performance. Iteratively, you need to monitor your model performance. In case the model performance decays, you need to retrain your model, right? You need to retrain model. So first you need to check, right, whether it is due to the concept drift, model drift, or data drift, right? So you need to, based on which you need to iterate the process. Hence, machine learning life cycle is an iterative. It is not a linear. The life cycle is not linear. It is an iterative thing. Okay. So now you got a fair amount of idea about the machine learning life cycle. We discussed in detail each and every phase, what tools we can use, everything in the past. Probably we will share the video if you are okay, the link and all later point in time. Okay. So next one is the stage-wise tools. Yes, this one I'm going to skip it now. Okay. All right. So next, what we'll do is 1 second here.